we will come across a term called stoichiometry and stoichiometric calculations. What is the actual meaning of this term stoichiometry? It is actually a quantitative relationship between the reactants and products in a chemical reaction. We know that there are reactants, say A plus B forming C plus D. Then this left hand side of the part of the reaction, chemical reaction, it's known as the reactant side, and this is the product side. Now, whatever quantitative relationship, whatever information in regard of this equation we can obtain out of it, of course, it's balanced equation form, that is known as stoichiometry. Here we can talk about mole to mole, mass to mass, and many other information in relation to the reaction. Let us see one or two examples. For doing stoichiometric calculations, we may need this concept, percentage composition. See, it is the number of parts by mass of an element or component in 100 parts by mass of the compound. What does it mean? Suppose I want to find the percentage composition of an element in a compound. Then how are we supposed to do it? So we'll do like this. The mass of that element in the compound. What is the mass of that element? Divided by molar mass of the compound into 100. Like, if I have to find the mass percentage of each element in water, say water is H2O, and I'm supposed to find the mass percentage of each element, or the percentage composition of each element in water. Now the molar mass of H2O is how much? Is equal to 2 plus 16, which is equal to 18 gram per mole, because I'm using the term molar mass, so I have written gram per mole. In that case, if I have to write the mass percent of H, then it will be how much? What mass of hydrogen is present in H2O? I can see 2. 2 out of the total mass, that means the molar mass of the compound, it is 18 into 100. Likewise, we can do for oxygen, how much it's present? 16. 16 parts by mass of oxygen is present in 18 parts by mass of the compound H2O, expressed in percentage, so into 100. Let us see an application of percentage composition. Calculate the mass percent of calcium, phosphorus and oxygen in calcium phosphate. First thing what do we need is, we need to find the correct chemical formula of calcium phosphate. Calcium ion is written as Ca2 plus. So calcium is having a valency 2. Phosphate, PO4 3 minus. So I can say phosphate is having a valency 3. So crisscross of the valency to write the chemical formula. 3 comes here. So Ca3 PO4 whole twice is the chemical formula. Now to find the molar mass of calcium phosphate, 3 into atomic mass of calcium plus 2 into atomic mass of phosphorus plus 4 2s are 8. So 8 into the atomic mass of oxygen atom. That is equal to total 310 gram per mole. Now one by one we need to find the mass percent. So I can say mass percent of calcium will be, how much of calcium is present in total? It is 120. 120 out of the total mass of the compound, that means molar mass of the compound. So 310 into 100 when it is expressed in percentage, and it comes out to be 38.71%. Like this only you can calculate the mass percent of phosphorus. It will be again 62 divided by 310 into 100. Mass percent of oxygen, you can calculate it 128 by 310 into 100, or you can subtract the mass percentage, the summation of the mass percentage of calcium and phosphorus from 100, and you can get the mass percent of oxygen. Now, if you make any mistake in the calculation in the first two parts, then your third answer will have error if you subtract the summation of first two from 100. So please be careful in your calculations. Now that I had already said that stoichiometry and percentage composition is linked up, let us see a numerical over here, an application of it. Chlorophyll contains 2.68% magnesium by weight. So chlorophyll is the green coloring matter of plant, we all know. Calculate the number of magnesium atoms in 2 gram of chlorophyll. So how are we supposed to solve it? 2.68% magnesium by weight means 100 gram of chlorophyll will contain 2.68 gram of magnesium in it. So we can find out how much of magnesium is present in 2 gram of chlorophyll. So how to do? Mass of magnesium in 2 gram of chlorophyll will be actually equal to 2.68 by 100 into 2. So this comes out to be 0.054 gram. This much of chlorophyll is, this much of magnesium is present in 2 gram of chlorophyll. Now what do we need? Calculate the number of magnesium atoms. Atomic mass of magnesium is given 24. So we can say that 24 gram of Mg will contain, Avogadro number of atoms contains 6.022 into 10 to the power of 23 atoms. This many atoms it contains. And what we got over here, therefore 0.054 gram of magnesium will contain how many atoms? 6.022 into 10 to the power of 23 by 24 into 0.054. This many atoms. You need to calculate it. So do practice calculations at home without using a calculator for your exam. In stoichiometry, we have also said there are relations like mole to mole, mole to mass, mass to mass. So these interrelations in any chemical reaction and any problem related to these can be solved like this. How many moles of CO2 will be obtained when 0.274 mole of C2H5OH is burned? Now C2H5OH is what? It's ethanol. Now from the junior classes 9 and 10, we know combustion, it's hydrocarbon, it produces carbon dioxide and H2O. So first we need to frame the equation, we need to balance it. Balancing is a must here. Until and unless I balance it, I cannot say how many moles of the reactants is giving how many moles of the product. We can see 1 mole of ethanol reacts with 3 moles of oxygen to give 2 mole of CO2 and 3 moles of H2O. I have only written for CO2 and ethanol. The reason is that is what is asked here. How many moles of CO2 will be obtained when 0.274 mole of ethanol is burned? So I can see from here that when 1 mole of ethanol is burned, it is giving me 2 moles of CO2. So if 0.274 mole of ethanol is burned, then how many moles of CO2 I will get? 2 by 1. So into 0.274, this many mole. And this comes out to be 0.548 mole. This is your answer. Well, now we can see mass to mass relation. Calculate the amount of water. G is written, that means in a gaseous form, produced by the combustion of 16 gram of methane. So here we need to mention the states also. Gaseous form, this is also gaseous form, all are in gaseous form. Now how much is the amount of water produced by the combustion of 16 gram? From this equation, we can only talk about the stoichiometry, like what is the mole relation between the reactants and products. 1 mole of CH4 reacts with 2 moles of O2 to form 1 mole of CO2 and 2 moles of H2O. Now, since it is given in mass, we need to convert mole to mass. So when I convert mole to mass, this 1 mole of CH4 is equivalent to how many gram of methane? That means molar mass. So 12 plus 4, that gives me 16 gram of methane. So 16 gram is only asked. So 16 gram of methane. How much is the amount of water produced? So 16 gram can give me 2 moles of water. Now this is needed to be converted to mass. So I will say 2 moles means 2 into the molar mass of water. So that is 2 plus 16, that is 18, and this comes out to be 36 gram, which is your final answer. Next, let us see mole to mass relation. See, this reaction we have seen in the preparation of oxygen we have seen. It's actually a catalytic decomposition of potassium chlorate. So if this is the reaction, the question is, for any experiment, we need to use 2.4 moles of oxygen. But the oxygen that we are using in that experiment we will obtain it by this reaction. So the question is, how many grams of potassium chlorate must be decomposed such that you can obtain 2.4 moles of oxygen, which you can use in some other experiment. So for that, we just need to take down the equation. So the equation is taken down. We need 2.4 moles of oxygen. By this reaction, we can prepare 3 moles of oxygen. So what is the weight, or rather how many grams of potassium chlorate is needed for this? So for 3 moles of oxygen to be prepared, we can use 245 gram of potassium chlorate. Therefore, to obtain 2.4 moles of oxygen, how many gram of potassium chlorate is needed? How many gram is needed? 245 by 3 into 2.4. This is the calculation. You do the calculation and get the answer. Okay, for the mass to volume relation, we have a numerical. Let's see. Calculate the amount of potassium chlorate, KClO3, needed to supply sufficient oxygen for burning 112 liter of carbon monoxide gas at STP. It looks confusing because it has two chemical reactions. See, you are using oxygen for the combustion of CO to form CO2. That means oxidation reaction is taking place. CO is getting oxidized to CO2. Fine. Now for this reaction, you need oxygen to be supplied. As per the stoichiometry, we can see 1 mole of CO reacts with 0.5 mole, half a mole of oxygen to produce 1 mole of CO2. But this oxygen that you are using for the oxidation of CO to CO2 needs to be obtained by the thermal decomposition of KClO3, potassium chlorate. So from this stoichiometric relation, we can see 2 moles of KClO3 by the method of thermal decomposition produces 3 moles of oxygen. So 2 moles of KClO3 corresponds to 2 into the molar mass of KClO3, that is 245 gram of it. So 245 gram of it can only produce 3 mole of oxygen. But we actually want 2.5 mole of oxygen for burning 112 liter that we have already calculated. So we need 2.5 mole. So 3 mole of oxygen is obtained from 245 gram of KClO3. Do write complete statement during your exam. So 3 moles is obtained from 245 gram of KClO3. So 2.5 mole of oxygen will be obtained from 245 by 3 into 2.5. This many gram of KClO3. Check your answer and it should come out to be, I think, 204.167 gram. Do check it. Now volume relation. There is again another numerical for its application. What volume of oxygen at STP is required to effect complete combustion of 200 cc of acetylene, that is C2H2? And what would be the volume of CO2 formed? So we need to write the reaction for the combustion of acetylene. And this is the reaction. We can see 2 moles of acetylene reacting with 5 moles of oxygen. Now we need to find out 200 cc of acetylene actually will react with how many cc of oxygen. So we need to convert it to the volume relation. 2 mole is equivalent to 2 into 22.4 liter or 22400 cc. So we have converted the mole relations to the volume relations, and then we have got the answer. So after this, the second part says what would be the volume of CO2 formed. So CO2 formed, here we can see 4 mole of CO2 is formed from 2 moles of C2H2. So we'll use this same thing and we will say that 4 mole is equivalent to 4 into 22400 cc of CO2. So 2 into 22400 cc of acetylene produces 4 mole equivalent to 4 into 22400 cc of CO2. Therefore, 200 cc will actually form, 200 cc of acetylene will form how much cc of CO2? Unitary method and get the answer. Thank you all of you. I think the concept of stoichiometry, the calculations related to stoichiometry, I really tried to cover up the topic with at least one example of each. Now, after coming from class 9, 10, when you come to class 11, you feel yourself to be in between a huge syllabus. So let us try to cover up bits and bits of the syllabus and practice regularly. All the best.